First one was done well. We've got keep the bottom the same times by the derivative of the top. Negative log of x will be negative 1 over x minus keep the top the same minus times by the derivative of the bottom over the bottom squared. As far as what would be in the back of the book for this one, well, when we're simplifying the top, this will just be negative x to the 4 minus 2 minus natural log of x times 5x to the 4.
Mr. Rock, are you in your classroom?
I am.
Okay.
Keep deriving. I'm so confused. All right, now we can factor out, maybe we'll take out a negative x to the 4. That would leave us with 1 minus 5 times and if you wanted to simplify this further, we're going to be left with only x to the 6 on the bottom, a negative on the top. 1 minus 10 will be negative 9 plus the natural log of x. I'd probably distribute that negative again. That looks like a pretty answer. Oh, 5. There's a 5 there, right? I guess that's what happens when you're not all there. Yeah, I just simplified 4 of them here with this to be 6. So that's what it would look like in the back of your book when you're simplifying. So when you're, again, doing the homework, you're going to want to practice matching it up so you can practice those algebra skills. Now this next one was the one that was causing some grief. And this is where I said before, the fact that the derivative of e to the x stays the same causes issues for people. So first of all, what I'm going to do here is I'm going to just change this square root of x to the half. And you have to recognize that there's a chain rule here. I'm going to put a set of green brackets around that x to the half. That x to the half is a function inside the e to the x function. So if we're thinking of working our way outside in, we would hit the e to the x function first. So when we do the derivative, since our first function is e to the x, the derivative of e to the x stays the same. Then we have to do the derivative of the function inside, because that's a chain rule. The function inside, that's why I put it in green in the brackets there, is x to the half. So the derivative of that, put that in green brackets just for fun, would be that. So we did a derivative of e to the x first, and that meant we just rewrote what we had before. So it feels like we haven't done anything, even though we did do something. And then we do the chain rule and do the derivative of the function inside. And then the third one on this page. Okay, I'm going to put a dot here because we have two functions multiplied by each other. And keeping with the same color coding from last time, I'm going to put the 5x in brackets because it's a function inside of the natural log function. We're going to use our product rule. We're going to keep one the same times by the derivative of the other one plus keep the other one the same times by the derivative of the last one. Now the derivative of natural log of 5x, it's a chain rule. The first thing we run into is the natural log. The derivative of natural log is 1 over whatever's inside. Hello?
Here
we go. Okay, so we have 1 over 5x, because that's the derivative of the outside, And then our function inside in the green brackets is 5x. What's the derivative of that? 5. So you'd multiply this by 5. I'm going to put that in green brackets just to help you see that if you're looking at this later. So you could simplify this. You could factor out a 3x. Those 5's at the end could cancel out. It's not, well, if it's a constant in there, okay, it will always simplify because, I mean, one way to look at it, if you use your log laws, okay, this is a good question. So this one's done, but if I had any number, natural log of 12x, 19, just using our favorite number of the year. Natural log of 19x, okay, if we think of this as a chain rule, then the derivative will be 1 over 19x, and then the derivative of the inside is 19. And good observation, will they always cancel out? Yes. Now, we can explain that by using our log laws, because another way that I can write natural log of 19x, I can think to myself, well, this is 19 times x. So I could use my log law and say that's the same as natural log of 19 plus natural log of x. And natural log of 19 is a number, so when I do the derivative of that, it would be 0 plus derivative of natural log is 1 over x. So your answer to your question is yes. No matter what number I have there, they'll always cancel out, and it will just be 1 over x. And that's two different ways of showing why that happens. That only works if they're multiplying. If it was a natural log 5 plus x, that would be a different story. Or 5 plus 3x would be different yet.